All right, so what point is at negative 5, 4? Is A. What point's at 3, negative 1? L at 3, 5. Q at 4, 1. At 2, negative 3. And then negative 2, negative 2 is H. Okay, where's G? Negative 4, 1. Where's R? Is it 1, 4? V? Negative 4, negative 3. B? Is 0, negative 4. M? Negative 2, negative 1. And then F? 5, negative 4. Okay, so this week we've talked about 3 different transformations. We've talked about translations, which is a slide. We've talked about reflections, which is a flip. We've talked about rotations, which is a turn. And today we're going to talk about our 4th one, which is a dilation. Now, the first 3, translation, reflection, rotation, are all what we call isometries. It does not change the shape or size. A dilation is not an isometry because it is going to change the size. All right? So a dilation is a transformation that enlarges or reduces a figure. So in a dilation, we use a scale factor. Okay? We use a scale factor. So a scale factor is a number multiplied to change the size of a figure. Okay, a scale factor is a number multiplied to change the size of a figure. So, if the scale factor is greater than 1, it produces an enlargement. In other words, it gets bigger. If the scale factor is less than 1, it produces a reduction. In other words, it gets smaller. And I'm not including any negative scale factors in what I'm talking about here, just all positive numbers. Okay, looking at number 1, we are going to dilate this figure, okay, by a scale factor of 3. Ooh. Okay, so we're going to dilate that rectangle by a scale factor of 3. So here's what I need to do first is I need to figure out what the coordinates of each of these points is. Now, this is for B prime, so I'll be writing my new dilated numbers in there in a second, but I'm just going to write B next to it, okay? So where is B at? Negative 1, negative 2. Okay, I'm just going to write it kind of to the side here. Where is C at? 2, negative 2. Where is D at? 2, 3. And then where's E at? Negative 1, 3. Okay. So that's the coordinates of the original points, of the pre-image points. Now, like I said, and what shows up here is we're going to dilate by a scale factor of 3. So all I'm going to do is I'm going to multiply every single one of these numbers by the scale factor. Okay? Every single one of these numbers down here gets multiplied by 3. So, what is negative 1 times 3? Negative 3. What is negative 2 times 3? Negative 6. Okay, so this will be the coordinates of B prime, of the image. Okay, now for this one, again, my scale factor up there, it says is 3, so everything's getting multiplied by 3. So what is 2 times 3? 6. And then what is negative 2 times 3? negative 6. And we'll come back and plot these points in just a second. Okay, now for this one, what's 2 times 3? 6. And then 3 times 3 would be 9. And then finally for E, good, negative 3, 9. Good. Negative 1 times 3 is negative 3, and 3 times 3 is 9. Okay, so let's plot the points for the new rectangle here. So negative 3, negative 6. Okay, 6, negative 6. 6, 9. And then E prime's at negative 3, 9. So we started off as the red one, and we ended up with the blue one. So was this an example of an enlargement or a reduction? Did it get bigger or smaller? It got bigger, right? This is an enlargement. Scale factor is more than 1. It's 3, so it got bigger. Okay, number 2. So I'm going to take this triangle. All right. So I need to find the coordinates first. So what's the coordinates of L? 5, negative 5. What's the coordinates of M? 10, negative 5. And then N is at 0, 5. Now this one, the scale factor is 1/5. So what I'm going to do is I'm going to take every single one of these numbers and multiply it times 1/5. Okay, so you just type that in your calculator or whatever. But if you type that in, what is 5 times 1/5? Is 1. Yep. And then what is negative 5 times 1/5? Is negative 1. Yep. Okay, what is 10 times 1/5? 2. And then what is negative 5 times 1/5? Negative 1. And then 0 times 1/5 is 0, obviously. And then 5 times 1/5 is 1. So those are going to be the coordinates of my new triangle. So we have 1, negative 1. We have 2, negative 1, and 0, 1. Just like that. Okay, did this get bigger or smaller? Smaller was a reduction. Okay. And again, I could have said that before we did anything. Scale factor is less than 1. 0.2. 200ths. Okay, one more. So on this one, all right, we kind of got this. So what are the coordinates of T? Negative 10, negative 15. What's the coordinates of U? 0, negative 10. The coordinates of V? Negative 10, negative 5. And then W? Negative 5, negative 10. All right, now on this one, we're using a scale factor of 1.2. So again, all I'm doing is, that's the number I'm multiplying by. It's what scales me up or down. In this case, it's going to scale it up. It's more than 1, just a little bit more. So it's not going to be a huge difference, but it will be a little bit bigger. So what is negative 10 times 1.2? Negative 12. Okay, and what is negative 15 times 1.2? Negative 18. Okay, 0 times 1.2. 0, negative 10 times 1.2. Negative 12. Negative 12. What's negative 5 times 1.2? Negative 6. And then negative 6, negative 12. Okay, there's T prime, U prime, V prime, and W prime. Okay, and this is an example of an enlargement. Slightly bigger.